Okay guys, here we go. We're in geometric series town now. So just like we started with arithmetic series, the top list of values, and I did use the word list, is a sequence. When I put plus signs between it, it becomes a series. Now in a sequence, just a reminder, you would have this formula, a sub n equals, and then a1 times r to the n minus 1. That is a sequence formula. It is. And that is used to find a certain singular location in a list of numbers. But a series, of course, we don't use a sub n, we have an s sub n to find the total number that we're going to add up. So once again, on this practice sheet, they're going to give you something that looks like that and then say to, 10 terms. All right, so we already know this type of notation. We do. This is reserved for series. But what we do not know is what is the formula for a geometric series? Well, it's this, a1 times r to the n minus 1 over r minus 1. That's the formula, flashcard city, that we would want to use for a geometric series. Now, be careful because this is where it gets kind of tricky. When I say a1 times quantity r to the n minus 1, it's not the same as when I do it up here when I go, a1 times r to the n minus 1. Be very cautious. Don't get r to the power of n minus 1. Don't get that confused with this in this formula. Okay? That is a big goof. So, let's look at this. If you look at the series I created, I have an A1. I do. And the A1 is 1/6. And you might look at that and go, oh, I figured out what the R value is. The R value for this is 2. But if you do not see the R value, if you do not see it, and you say, well, take any number in the list, divide by the one that came before it. Take any number in the list, divide by the one that came before it. That's how you find R. And then, of course, this is the same as it's always been. Flip and multiply. So it would be 2/3 times 3 over 1, and bam, boom, there's 2. Or 1/3 times flip it over 6 over 1, bam, boom. You get 2. So there's my R value, my common ratio. The word is ratio, division. And then how many terms they want us to add up? They want us to add up 10. Now the thing is, when things are geometric, they can get way messier looking than they do when they're arithmetic. It is true. It's a fact. So the thing is, you got to be really cautious with the formula. I'm just going to write out 10 numbers and add them up. It's a lot of work to do that because if you look, you're going to get a bunch of fractions. And then you're adding fractions, adding fractions. It's not fun. The formula is a rule of thumb is this. If they ask me to add up to 5 numbers in a list, 5 terms, I will write out 5 terms and add it up. But believe it or not, by the time you get to like the 6th or 7th number in a list, it's usually faster to use the formula, but there are some pitfalls when you use this formula. So that's basically what I'm going to coach you through in this lesson. So what do? I want to add up these numbers. So I need an A1 because it's in the formula. I need an R and I need an N. So let's plug some stuff in and we'll call it the 10th partial sum. So I would say A1 times r to the n minus 1 all over r minus 1. Now this is the best situation we can ever find ourselves in, because in this formula you will sometimes run into our buddy the double fraction. And nobody likes double fractions. So the best thing that can happen for us is in the bottom we have this. 2 minus 1 is 1, and then I don't have to write a double fraction to finish this off. Instead, I just have to say 1/6 times, now inside the parentheses, I'm going to do 2 to the 10th power, which is 1024, minus 1. So now I have 1/6 times 1023, which I can make it look like a fraction. And then I could say, hey, I wonder if that turns out to be a nice, pretty number. Does it reduce is my question. So don't just walk away from it. If you do this, I'm going to just multiply 1023 over 6. Well, are you sure? What if that number happens to reduce? So word to the wise. Punch it into your calculator and math frac that thing, because you will get 341 over 2. Now, be on the lookout, because I'm going to remind you of this. Or you could write it as a mixed number, 170 and 1/2. But I'm going to tell you, this is the golden rule for me. If I give you a fraction in the original question, don't give me a decimal answer. So 170.5, I will mark you wrong. And I will remind you on the test. It'll say write your answer as a fraction. So the thing is, guess what? This is all chocked full of fraction action. So the answer should be in fraction form. This is an okay answer. I don't hate it. That's an okay answer. I don't hate it. This would be you didn't reduce it, so I'd take a point from you. But what I'm trying to get at is, look at how weird that answer is. By the time you get to the 10th number in that list, and then you add them all up in this list to 10 terms, take my word for it, it's much easier to just plug it in the formula. It is. So what I want to focus on is not the ones that I would just write out the numbers and add them up. I want to focus on the ones where I would use the formula to help me do the problem. So let's look at another one. And I'm going to say something like this. The list is going to start this time with, let's say, 4. But then I want you to add this, and then I want you to add this, and then I want you to add this to, let's say, 8 terms. Pick a different number this time. So once again, like I said, 8 terms, you could write out 8 terms and add them up. Oh, and in this one, there's no fractions. So you know what? You actually don't have that tough of a deal working for you. But I want to practice using the formula, so I would say the 8th partial sum is equal to, now what do I need? Well, I need A1, I already see N, what's R? Take any number in the list, divide by the one that came before it, and in this case you get R is 3. They want me to add up 8 terms, and my first term is 4. So it's not in my DNA anymore. It's in my RNA. I know. It's hilarious. I had to make that joke. So I will stop now. Here is A1 times R to the N minus 1 all over R minus 1. Now, here's the nice thing. This one is still, well, it's not the perfect storm. That's not going to give me a 1. Oh, dang, I just noticed that. Hang on. Oh, R minus 1. It's not a 1 in the bottom. It's a 2. But what I'm trying to tell you guys is, whenever you can, you want to try and eliminate this fraction-y look. So you could either divide top and bottom by 2, or you could say, hey, 2 goes into 4 twice. I could do that. I totally could do that. And then what's my answer going to be? Well, it's going to be 2 times whatever 3 to the 8th is. So I go, what is 3 to the 8th? 3 to the 8th is 6,561 minus 1. So I get 6,560 times 2. And I get, for my 8th partial sum, I get 13,120. See, believe it or not, look at that. You go 8 terms out and you add them up, you're already in the big time. You're already in, like, how many friends I have on Facebook. Sure, they're imaginary friends, but they're mine. Okay, that one was hilarious. So, let's get into the ones that get a little sticky. Let's get into the ones that are kind of like not our friends. These are the ones you got to be careful about. So something like this. Let's just say like a 6, excuse me, I feel a sneeze coming on, plus 4 plus 8/3 plus ding, 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 ding. And let's go to, I don't know, how about we'll go 9 terms. Or they could just show you the list and say, they could say something like this: find S sub 9, which means the 9th partial sum. But, once again, take any number in the list, divide by the one that came before it. So if I did 8/3, let's just say 8/3 divided by 4. Well, divided by 4, I'm going to flip and multiply. Oh, I get 2/3. So is this true? Take any number in the list, divide by the one that came before it. Hey, it is also 2/3. So that's R. So I go, A1 is 6, R is 2/3, N is 9. So let's start plugging this mess in here. And we say A1 times R to the N. Now, I'm going to be real careful here, because if I'm going to use my calculator, which I will, I'm going to try and let it help me. I know my calculator might make a mistake unless I tell the calculator the entire fraction 2/3 is going to be taken to the 9th power. Then I will subtract 1. But here's the trick I want to make sure you see. R minus 1. Now this looks horrible because there's all kinds of fraction action. And you could make this look a little simpler. I'm going to work right below it for a second. 6 times 2/3 to the 9th minus 1. 2/3, take away 1, is negative 1/3. So here's the thing. Double fraction, ooh, ick. Do this for yourself. Multiply the bottom by negative 3. But if you do that to the bottom, multiply the top by negative 3. If you have any kind of fraction action down there, do that first. Clean this up first. It'll help you so much. Clean it up first. Then take a look at what we have. I'm just going to keep going downward. I have negative 3 times 6, that's negative 18. Then times 2/3 to the 9th minus 1. Well, what is 2/3 to the 9th? Because I'm doing order of operations. I have to go inside the parentheses. So I go 2/3 to the power of 9, and my calculator gives me a super ugly, horrible decimal. And it's still going to be this ugly, ugly number that I just got, minus 1. So I'm going to keep it on my calculator for now. I'm going to say minus 1. And then I get a super ugly, different, horrible decimal. But I'm still going to be multiplying that answer times negative 18. So if I do all of that stuff, and then I look at my answer that I have from just all of this going into the calculator, then you should be looking at what I'm looking at, which is 17.53177,869. Now, take a look at the original. Did I give you fractions in the original? You better believe it. If you write down the answer 17.531 blah, 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 I'm going to ding you for it. Because guess what? Math frack it. And you might go, oh my gosh, that is the ugliest looking number. Yeah, it's not pretty, but play by the rules. 38,342 over 2,187. That is the 9th partial sum for that series. This part right here where I say clean up the bottom first, that is a major thing. Now the other part was I slowly, methodically went one step at a time with my calculator to get this value. But remember, on your calculator there is a math button, and you will math frac whenever possible. Okay, you with me? So, let's play around one more time. Let's do a little bit more. But this time we're going to write it like this. They're going to say something like this, the sixth partial sum. And then they're going to pull one of these on me. And they're going to use K maybe, who knows? And they're going to say, could you add up this like that? And you go, dang, what the heck is that? Well, that's sigma notation. Guess what? If I plug in, oh, sorry, that should be a K to match my index of summation. So I'll put K, right? K. But if I put a 1 right there, that's where it wants me to start, I would get 3 times 1/4 to the 0 power. Well, the 1/4 to the 0 is 1. 1 times 3. Oh, so the first thing that comes out is 3. That's what comes out. Now, I could continue to plug numbers in. I could plug in 2. If I plug in 2, I'll get out 3/4. If I plug in 3, I will get out, what I'm trying to get at is, I could do this. I could keep plugging stuff in. But remember, when you plug in 1, that guy's A1. So I go, oh, wait a minute. I see a pattern here also. It appears to me that R is 1/4, and it is. See, these things have a certain look to them. They have a certain vibe, but I don't want to get sidetracked. I'll come back to that in a second. I got an R value. I got an N value. I got an A1 value. Let's do it. I'm going to say, hey, I need to find out what the sixth partial sum is. So it's going to be A1 times R to the N minus 1 all over R minus 1. And please take my advice here. Clean this chunk of junk up first. 1/4 take away 1. That guy's negative 3/4. That's what he is. So let's work down again. We're going to work down again. I'd say 3 times 1/4 to the 6th. Oh, sorry. God, that should have been a 6. To the 6th minus 1 all over negative 3/4. And then use my hint. Multiply the top and bottom by that guy's reciprocal. If you do, you get rid of the double fraction look. So I'm going to multiply by negative 4/3. Negative 4/3. Then everything in the bottom cancels, but that means I have to do it up here. Negative 4/3. Cancel, 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 cancel. All that stuff's gone. And then look up here. Look up here. Kabam! Kabizzle. What? I have negative 4 times 1/4 to the 6th minus 1. Well, let's grab our calculator. 1/4 to the 6th. How bad could that be? 1 divided by 4 to the power of 6. And I get on my calculator, something. But don't panic yet. I'm going to say minus 1 to that number. And then I get some super decimal, negative 0.99975585594, but I'm going to take the answer that I got from my calculator here, and I'm going to multiply it by negative 4, and I get some 3.99 action going on. What do I get when I take that number here times negative 4? What did I end up with? My calculator says it's 3.999023. I'm running out of room, but I'm going to math frac this thing anyway. And it won't math frac. My calculator will not do it. Well, that's because I'm using my TI-83. So let's try this one more time. I'm going to grab my TI-84, which is a little bit newer, a little bit more power in the processor. Maybe it'll do it. So let's try it again. 1/4 to the 6th. I got that E number again. Minus 1. I got that number again. Times negative 4. I got that number, the 3.999 thing, so I'll just math frac it. And I go, oh dang, snap. How awesome is it that my newer calculator with a much larger processor was able to give me the correct answer, which is 4,095 over 1,024. This would be the 6th partial sum. Now, I told you at the beginning of this lesson, when they ask me to add up the first 5 numbers, I'm not so bad. But when they get to 6 or 7 or 8 or 10 crazy numbers like that, you start running into some hideous values that are really nasty. So I want to help you out because I don't want somebody who's using a calculator that sticks them with that. So let's just talk about what is actually happening with our numbers. And you know what? You might find yourself in this position where you're trying to write your answer as a fraction, and your calculator leaves you high and dry. But don't fret. You know how to think. A calculator does not. So let's pick up right here at the painful part. See, I have negative 4 times 1/4 to the 6th minus 1. Now, the trouble began right here when I did this, 1/4 to the 6th. But you know what? If I take matters into my own hands, I can get this part to work out for me. Check this out. Order of operations. 1 to the 6th power on the top is 1. 4 to the 6th power on the bottom is 4,096. Take away 1. Well, let's use the trick they showed us all the way back in the 4th grade. You can write this number like this. 4,096 divided by itself, that's the same as 1. But what does that allow me to do? It allows me to subtract now. I can say inside the parentheses, not outside. I didn't do anything with this negative 4 yet, but inside those parentheses, I have 1 over 4,096 minus 4,096 over 4,096. What do I get? Well, 1 minus that 4,096 is negative 4,095 over 4,096. I'm going to take that times negative 4. Now, if you multiply that on your calculator, it's going to bring you back to decimal town. So you have to take matters into your own hands at this point. You're going to have to say to yourself, can I reduce this thing? And let's see. Wait a minute. Did I make a mistake here? I think I blew it somewhere here. Let me just double check, guys, because I think I have a glitch somewhere. Hang on. 4 to the 6th. Oh, crap. My calculator is totally not helping me there. What is that? 4,096 minus that. That would be 1 minus that. Yeah. Okay, so let's see where we roll here. Let's see if this will reduce, and it should. I'm wondering why I am not getting the same answer. And you guys probably see why. Let's see. Divided by 4. Is it? Yeah, it's 1024. This on the bottom would be 1024. So let me see. Where's my glitchy thing happening here? 1, 4. Crap. I can't see it yet. I cannot see it. Why can't I see it? Minus that. That would be that. 1,095. Wait. Oh, duh. I'm right. No. I was thinking, why isn't this answer the same as this answer? But it is. I was looking at the wrong number. I'm good. Duh. This goes into that one time. This goes into that 1,024. Whoop. 1,024 times. Sorry about that, guys. Had a brain fart for a second. So I got a negative times a negative. That's positive. And then on the bottom, I got 1, 2, 4. Boom. That's that. So whether or not your calculator locks up on you, you can still muscle it through and get it to work. Now, I sidetracked myself. I'm sorry about that. Here's what I want you to see. This is the last thing I need you guys to understand. Here we go. Bear with me. Let's suppose I give you something like this. N equal 1 to 5 to n plus 3, right? And let's suppose I give you something like this. N equal 1 to 5. And over here I go 6 times 1/2 to the n minus 1. They don't look the same, do they? They don't at all. Now, here's where I want you to kind of just think for yourself for a second. One of these guys is arithmetic. One of these guys is geometric. They're both sigmas. They are. But one of them is arithmetic. See, arithmetic stuff has a certain look to it. Geometric stuff has a certain look to it. So just, if you have to, pause it for a second and look at it and go, you know what? I have seen stuff that looks like this. That stuff is always arithmetic stuff. 2n plus 3, negative 4n plus 5, n minus 6. If I can make it look like one of these type of characters, I know it's going to be an arithmetic situation. See, and if it's arithmetic, then I know that my brain is supposed to go to this formula. This guy is the dude I need to use. But if it's geometric, it has a certain look also. Let's take a look at that guy. That guy looks super duper geometric. Now, think about what the geometric sequence formula looks like. Like there's an A1, there's an R. There's a pattern in this. That's A1. That's R. But this is not a sequence. What makes it so much not a sequence? As soon as you see sigma, you know you're in Seriesville. So I wouldn't use this formula, although that's the key to like recognizing the difference. Things that look like this are geometric looking things. It's always true. This is a geometric guy. This is a geometric guy. So up here, I got my R value. I got my N value. I got my A1 value. Now on this one, I said it only goes to 5. I only have 5 numbers to add up. So if I plugged in 1, I would get 6 times 1/2 to the 0. Oh yeah, I do get out 6. 6 is the first number. Plus, if I plug in 2, I'd get 1/2 to the first. Well, that's 1/2. 1/2 times 6, well, half of 6 is 3. Then the next one, what's half of that? 3/2. What's half of that? 3/4. What's half of that? 3/8. See, when it's only 5 numbers I'm adding up, it's really not a super big chore to write out that many numbers. you know? So that's where I always draw the line. If somebody's going to ask me for a fifth partial sum or a fourth partial sum or something, I usually just write it out. The only other time I just write it out and add it up is if they tell me to write the expanded form. So remember, when you write it out the long way, like this, that's called expanded form. So I could total it up that way, or I could plug it into the formula. So, be careful though. In mathematics, I've been telling you guys to be polite. I've been telling you to be polite for me. I'm going to use K 1 to 7. I'm going to do this. I'm going to go 3 times, what the heck, I've used 3 of it. Hey, I did this in the last one. I didn't write it down. Okay, so see this guy right here? This dude totally looks geometric. But this person wrote this problem out in a very impolite way. Do you guys see where the impolite piece of information is? It doesn't look like the other geometric stuff I've worked with. It doesn't mean this person's wrong, it just means they're impolite. See, usually it says K minus 1 right here. This guy didn't write a K minus 1. Well, what an impolite person you are. Well, how does that affect me? Well, here's how it affects me. This is still going to be R. That's still going to be R. This is still going to be the value I use for N. But you know what? That's not A1 now. That is not A1. If somebody writes something impolitely, you have to plug 1 in for that. If I put a 1 in there, then I would have 3 times 3 halves to the first, which means 3 times 3 halves, which means the first number that would have come out of that thing is 9 halves. That's your A1. Be on the lookout for that. They're going to do that to you on one of these problems. They're going to do that to you for sure. Okay, so how do you remedy that? You got to go get yourself A1. And how do you find A1? A guaranteed way. This is always, what I'm about to tell you is always true. A guaranteed way to find out what the first number is to plug in 1. If the rule is written politely, then the first thing there, then this would be A1 if it was written politely. If this was a minus, there'd be no issue. But whoever wrote this one out didn't do it politely. So if you want to use the formula, you got to get yourself A1. Always true. Plug in 1 to find A1. All right. Let's go up and see what problems you must work through for me. Here we go. All the way to the top. Geometric series. All right. Now look, they have the formula there. They have an example. They have a solution. They have all that stuff, all that good stuff. So problem 1, 2, 3, 4, 5, 6. All of those guys right there, they're I'm looking. None of them have fractions in them except for number 5. So number 5, I would expect you to write your answer in fraction. It doesn't mean you won't get fractions for the other ones. I'm just saying, play by my rules. If the original problem contains a fraction, you will give me a fraction answer, and I'll remind you that on the test. But for these ones up here, 1 through 6, if you want to write it in expanded form and add it up, I'm not going to hassle you. If you want to use the formula, and it's right there, it's just really tiny print, which is really hard for my old man eyes. If you want to use the formula, go for it, but please show me your steps as you're working. But down here, these ones right here, 7, 8, 9, 10. One of these is written impolitely. Take a good look at problems 7, 8, 9, and 10. One of those is written impolitely. One of those, you have to plug in 1 to get a 1. Which one is it? Exactly. I'm not going to tell you. But if you ask me for help, I'll tell you. Anyway, the other thing is, of those problems, only one of them you must give me a fraction answer for. Which one would it be? The one that contains a fraction in the original. So that'd be 10. The other thing is, I don't want you guys to shy away from trying to use the formula, because the one on the test I'm going to make up, you're going to be like, I should use the formula. However, I do want you to understand this completely. For problems 7, 8, 9, and 10, for these ones right here, I want to make sure you practice it, so you must use the formula for these. And then on the bottom, I gave you 2 word problems. Now here's the thing with these 2 word problems. Neither of these word problems contains fractions in them. And I worked these out with fractions and with decimals. They are so gnarly with fractions. So I would never do something to you that I think is so beyond the necessity of the problem. So here's the thing. For number 11 and 12 down here, okay, for these ones, here's my hints. Number 1, definitely use decimals. Do not use fractions. Also, you're going to take your final answer and you're going to round to the nearest whole number. All right? And if you follow my instructions, the first 6, you do them any way you want. 7 through 10, you must use the formula. 11 and 12, I would use the formula. I totally would, by the way. Hint. But I would round to the nearest whole number if you want your answers to match my key. And here is my key. There is my key. So you may check your answers. And you will see that I wrote 2 answers in fraction form for 1 through 6. Just because I don't like repeating decimal answers. I don't. We're going to take care of repeating decimals in the next lesson. All right, guys, so geometric series. Knock them out. Get them done. And if you got questions, remember, ask them. I get paid to answer them. All right. Catch you later.